Alright, so here's our bank turn homework problem. And where do we start? So we start with sum of the forces equals ma. And what is acceleration as this car goes around in a circle? And we use sum of the forces equals mv squared over r. And how do we know what forces? And we do a free body diagram. And we have gravity down. And we have normal perpendicular. And which way is positive x? Positive x is towards the center of the circle. So what forces do we have? We have normal. Do we have all of normal? No, it doesn't point all on the x, so we just want the x component of the normal force. And how do you get the x component? You use cosine of your reference angle. And what would our reference angle be in this case? Our reference angle is actually 20 degrees because we have alternate interior angles of 70, and then that means that the end part up there is the complement of that, which is what's left over, minus 90, so it's 20 degrees. So we bring that down in here, and we have n cosine 20 equals mv squared over r. And the radius is 150. So now the question is, how do we find what the normal force is? For the normal force, you have to use the y direction. Sum of the forces is mass times acceleration in the y. And what forces do we have in the y? Is normal in the y? Yes. Is it all in the y? No, so we have to use sine 20. Is gravity in the y? Yes, and it's down, so we have minus g. What is acceleration in the y? Acceleration in the y is 0. The car's not doing anything up and down. It's going around in a nice flat circle. So then we algebraically solve for n by bringing g to the other side. And what is the gravitational force equal to? The gravitational force equals little m, little g. And now we substitute that into our x equation. And now again, we're trying to solve for v. So we're going to have to cancel out the m's and multiply both sides by 150. And now we're left with v squared equals. And we're going to evaluate sine and cosine at 20 degrees and substitute those in. And then we evaluate all of that. And then finally we take the square root and find out that the necessary speed is 64 meters per second.